We're going to begin chapter 10, section 2, which is where we perform operations with matrices. A matrix is just a rectangular array of numbers. It has m rows and n columns. The rows go horizontally, the columns go vertically. So if you look at this example right here, we have kind of these square brackets with a bunch of numbers on the inside. All right, it's always going to look something like this, rectangular. All right, and it looks like we have 1, 2, 3 rows. All right, in the first row we have a 1 and a 2. In the second row there's a 3 and a 4. In the third row a 5 and a 6. Now if you're looking at it vertically, we have 2 columns. All right, so in the first column there's a 1, a 3, and a 5. In the second column there's a 2, a 4, and a 6. We call the order of a matrix m by n, right? So however many rows by however many columns. This particular matrix has 3 rows and 2 columns, so this is a 3 by 2 matrix. All right, we also call these the dimensions of the matrix. The dimensions are 3 by 2. Each individual number that you see here is an entry, right? So when we say the word entries, which you're going to hear a lot this lesson, we just mean each individual number, right? So if you look here, counting all of these numbers, there are 6 numbers in this matrix, so we have 6 entries total. To perform matrix operations, the matrices have to have the same dimensions. If they do not have the same dimensions, then you cannot perform the operation. But the actual math here is super simple. All you have to do is add and subtract the corresponding entries. So if you look at this first page, we have a couple problems here. If you look at this first one, it looks like we're adding 2 matrices. We first want to check if this is even possible, right? So let's check. The first matrix has 2 rows of numbers and 2 columns, so this is a 2 by 2 matrix. The second matrix also has 2 rows and 2 columns. Since these dimensions are the same, we can perform this operation. All we have to do if we see a plus in between is we're going to add the corresponding entries. So I'm going to add the top left with the top left. So -1 plus 1 is just going to get you 0. We're going to add the top right with the top right. 2 plus 3 is 5. We're going to add the bottom left with the bottom left. 0 plus -1 is -1. And then we're going to add the bottom left with the bottom right with the bottom right. 1 plus 2 is just going to get you 3. All right, and then this would be your final answer. All right, simple as that. Should be super straightforward. All right, if you look at the next one, we're going to do the exact same thing, right? We're first going to check if this is compatible. It looks like here we have 2 rows and 3 columns, right? So this is a 2 by 3 matrix. The second matrix is also of 2 rows and 3 columns, so this is another 2 by 3 matrix. We are allowed to perform this computation. We see a plus in between, so we're just going to add the corresponding entries. So 0 plus 3, these are in the same spot, so I'm going to add them, is going to get you 3. Top middle with the top middle is 1 plus 4, so 5. The top right with the top right, -2 plus -1 is -3. And the bottom row, we're going to do the bottom left with the bottom left. 1 plus 2 is 3. Bottom middle with the bottom middle is 3. And bottom right with the bottom right, 3 plus 0 is 3. All right, so a bunch of 3s in this problem, right? But that is all we have to do for that problem. All right. Now, if you look at this one, it looks like here we have 1, 2, 3 rows and 1 column. So this is a 3 by 1 matrix. If you look at the second one, it looks like we only have 1 row, but 3 columns. So this is a 1 by 3 matrix. Since these do not have the same dimensions, we cannot perform this operation. I'm going to say that this is not possible. All right, and it's good enough to just say this, right? You don't have to give a whole detailed explanation, but a short little explanation just for the sake of your notes is that the matrices do not have the same dimension. All right, do not have the same dimensions. We can also multiply a matrix by a number. We typically will call that a scalar multiple. All you have to do is multiply each entry in the matrix by that scalar multiple. One way to represent matrices is with a capital letter. Sometimes you see like A, B, and C, sometimes X, Y, and Z. But typically, just to shorthand it, we do a capital letter to represent a matrix. All right, so to find 3 times A, all you're going to do is you're just going to multiply every single entry in A by 3. That's literally all that means, right? It shouldn't be that difficult at all, right? In this matrix, I'm going to go by each entry, and we're going to do 2 times 3, which is 6. Same thing with the next one. 2 times 3 is 6. 3 times 4 is 12. And then you go to the second row. Negative 3 times 3 is negative 9. 3 times 0 is 0. 3 times negative 1 is negative 3. And then we move on to the next row. 3 times 2 is 6. 3 times 1 is 3. And then 3 times 2 is 6. All right, there's nothing hard about this. Should be super straightforward, super easy. All right, let's look at the next one. Negative b, all you have to do is you can treat this like a negative 1. And then all you're doing here is you're multiplying every single entry in matrix B by negative 1. So let's write this out. 2 times negative 1 is negative 2. Negative 1 times 0 is 0. And then the next one's also 0. And then we go the second row. Negative 1 times 1 is negative 1. Negative 4 times negative 1 is 4. And negative 1 times 3 is negative 3. Move on to the second row. Negative 1 and negative 1 make a 1. Negative 1 times 3 is negative 3. And negative 1 times 2 is negative 2. Again, shouldn't be anything difficult about this. All right, all we're doing is multiplying each number on the inside by whatever number is in front. Sometimes what you'll see is a combination of 2 different scalar multiples. So we have 3a minus b. There's a couple ways that you could do this, but look at what we found in problems 4 and 5. We found 3a and we found negative b, right? So we already found these individual components. We found a 3a and we found a negative b. So what you can treat this as is you can treat this as a 3a plus a negative b, and then you're just adding these entries together. All right, so let me write it out. We know that 3a is this right here. So it is a 6 and a 12, negative 9, 0, negative 3, a 6, a 3, and a 6. Plus, we know that negative b is this matrix up here. So it's negative 2, 0, 0, negative 1, 4, negative 3, 1, negative 3, negative 2. All right, and so since these are the same dimensions, you can just add the entries together. All right, so 6 plus negative 2 is 4. 6 plus 0 is 6. 12 plus 0 is 12. Negative 9 plus negative 1 is negative 10. 0 plus 4 is 4. Negative 3 plus negative 3 is negative 6. And then the last row, we end up with a 7, a 6, and a 4. And then so this would be the answer to find 3a minus b, right? We get this matrix right here. This is where it gets a little bit tricky, and it's where you multiply matrices. So when you're multiplying matrices, they actually do not need to have the same dimensions. All right, what needs to happen though is that the inner dimensions need to be equal, and then the outer dimensions is just the dimensions of whatever you get when you multiply. All right, sounds a little confusing, but let's just use, for example, these 2 by 2 matrices here. All right, we know that this first matrix is a 2 by 2, and this second one is also a 2 by 2. These inner ones need to be the same. And if they are the same, then we can cross them out. And then our product, when we multiply, is going to be a 2 by 2 matrix. So for example, let's just say A is a 3 by 3, and B is a 3 by 2. All right, you wouldn't be able to add or subtract these, but you would be able to multiply just because the dimensions of A, again, are 3 by 3, and B is a 3 by 2. The inner numbers are exactly the same, so I would cross them out, and our answer is a 3 by 2. However, if, let's just say, we flip it, and we want to do B times A, that would be a 3 by 2, and then a 3 by 3. These numbers are not the same, so this would be not possible. You would not be able to multiply those. Now, it looks like there's a lot of writing here. I would rather just show you the pattern in an actual example as opposed to having you know exactly what this means. Just because this is true for a 2 by 2 matrix, but not always are you going to multiply two 2 by 2 matrices together. So I would rather just show you with an example how to do matrix multiplication. All right, so we have examples 7 and 8. We want to find A times B. The first thing we want to do is we just want to make sure that this is compatible, right? So let's look at the dimensions of A. The dimensions of A are 3 by 2 because there's 3 rows, 2 columns, and then B is a 2 by 2. Let's check the inner numbers. Let's put them side by side. The inner numbers are the same, so we are allowed to do this matrix multiplication. Our dimensions of the product is just going to be whatever's left over, and it's a 3 by 2. So I know for sure my final answer has to be a 3 by 2 matrix. All right? Now, when you're multiplying, if you're doing this first matrix times the second one, it's going to be row times the column, and you're going to do each entry by entry. All right? So we're going to do this first row times this second column. All right? So we're going to do this row and this column, and we're going to go left to right, top to bottom. All right? So the operation is going to be to do A times B. It's going to be -1 times -3 plus the next set of numbers that we see are a 3 and a 4. Again, it's left to right, top to bottom. All right, so how did I get that first, right? It's going to be a -1, so first entry by first entry, plus second entry by second entry. So 3 times -4, so plus 3 times -4. All right, let's do the exact same thing to find our next entry. All right, let me erase this circle right here, whatever I circled. All right, so this is just for the first entry, right? Our dimensions are a 3 by 2, so I need something else in this first row, and it's going to be this first row times this second column. All right, so again, we're going to go in order. I'm going to do the first times the first. So 1 times -2. I'm sorry, opposite, right? -1 times 2 plus a 3 times 1. All right? And that's it for the first row. All right, let's move on. So let me erase that now just to not confuse you. That's how we get the first row. In the end, we're going to simplify all of this, right? Now moving on to the second row, we're going to do the second row and this first column. So again, it's the same exact pattern, left to right, top to bottom. So it's going to be the first times the first, so 4 times -3. So 4 times -3 plus the second times the second, so -2 times -4, so plus -2 times -4. All right, and that's it for the first entry of the second row. Again, let me erase this. And now let's keep going. Let's move on. It's going to be the second row and the second column. So let's continue the pattern. It's going to be the first times the first plus the second times the second. So let me write that out. This is going to be 4 times 2 plus -2 times -2 times 1. All right, and that's it for our second row. We're going to need the third row now. All right, the third row, let me use a different color. All right, we're going to do the third row with this first column, but it's the same exact pattern. You're going to do from left to right, top to bottom. It's going to be 5 times -3, so 5 times -3 plus 0 times -4. All right, and then you're going to do the exact same thing with the last pair of rows and columns, right? So it's going to be the third row and the second column. So it's going to be a 5 times 2 plus a 0 times 1. All right, and then that's our matrix. We just have to simplify all of these now. So I'm going to do the top row that's in green, and I'm just going to simplify each entry. We know that -1 times -3 is 3. 3 times -4 is -12. And then 3 minus 12 is -9. All right, we'll do the same thing with the next one. -1 times 2 is a -2. Plus 3 times 1 is just 3. So -2 plus 3 is 1. All right, and now let's do the next row. -3 times 4 is -12. I'll do that up here. Plus -2 times -4 is a +8, and -12 plus 8 is a -4. We'll do the same thing over here. 4 times 2 is 8, plus -2 times 1 is -2, and 8 minus 2 is 6. All right, and then our last one is 5 times -3 is -15. 0 times -4 is 0, so we just get a -15. Here we get 5 times 2 is 10, 0 times 1 is 0, so 10 plus 0 is just 10. So this is the solution to our matrix. All right, this is how we perform the multiplication. All right, it's not the fastest thing in the world, but if you practice enough of these, you should understand the pattern and it shouldn't be that bad. All right, so that might have been a little confusing at first. We're going to try the second one, and hopefully we can follow along. All right, so again, I'm going to just start by saying that the pattern for these, I'm not going to start with the pattern, actually. I'm going to start with just seeing, is this compatible? So let's look at the first matrix. This one's a 2 by 3 matrix. The second matrix is a 3 by 2. All right, we're doing A times B, so let's look at the inner numbers. 3 and 3 are the same, so we can cross it out, and we know our answer is going to be a 2 by 2 matrix. So this is compatible. All right, let's start our pattern. All right, so we're going to do the first row times the first column. So let's set up a big matrix just to do all of this, and we're going to do the first times the first from left to right, top to bottom. It's going to be a 1 times -2. Right, so again, it's first times the first, then it's second times the second. So next we're going to do 0 times 1, so plus 0 times 1. Plus, this time we have three of them, right? So it's a 3 times -1. So plus 3 times -1. All right, so that is our first entry. Let me erase this just so that I can do the next entry. All right, next entry, I'm going to do first row and second column. So again, let me leave some room. We're going left to right, top to bottom. So it's going to be 1 times 4. We're going to do the first times the first, plus the second times the second, so 0 times 0, plus the third times the third, so plus 3 times 1. All right, and that's it for our next entry. All right, let's move on to the next row. Our next row, we're going to do the second row times the first column. And once again, it's the same pattern. It's going to be left to right, top to bottom. So 2 times -2 plus -1 times 1 plus -2 times -1. All right? And then we're going to do the exact same thing with the next one. I'm going to do this second row times this second column. All right, so let me erase this. All right, so second row, second column, same exact pattern as always. So it's going to be 2 times 4 plus -1 times 0 plus -2 times 1. All right, so give yourself plenty of room just so that you're able to do this computation. And now let's actually simplify everything, right? 1 times -2 is -2. 0 times 1 is 0. 3 times -1 is -3. And this is going to get you -5. So in our first entry, it's going to be a -5. We're going to do the exact same thing with the next one. 1 times 4 is 4. 0 times 0 is 0. 3 times 1 is 3. So 4 plus 3 is 7. All right. Let's do the same thing with the next row. 2 times -2 is -4. 1 times -1 is -1. And -2 and -1 is +2. Combine these, we should get -3. All right. Let's do the same thing with the next one. 2 times 4 is 8. -1 times 0 is 0. And -2 and 1 is just -2. So 8 minus 2 is going to get you 6. This is your final answer here. All right. It's a long process, but again, if you practice it enough, the pattern should be very clear. You just want to take your time and stay organized. The only way that you would get these wrong, apart from not knowing the pattern, of course, is you just make silly mistakes because you can't read your work. So you want to stay organized. Okay, so let's do the same thing over here. First, let's check if these can be performed. So we don't see a sign in between these two matrices, so we know that we're going to have to multiply. Let's first check, right? This is a 2 by 2, and this one's also a 2 by 2. So let's look at the inner numbers. They do match, right? 2 is the same as 2. So our answer is going to be a 2 by 2 matrix. So let's go ahead and perform this multiplication. So again, I'm going to set up a big matrix. We're going to do first row times first column. So it's going to be 3 times 1 plus 4 times 0. All right? And that's it for that first row. For that first entry. All right? And then we're going to do first row, second column, right? So 3 times 0 plus 4 times 1. And then let's do the next column now. Next row. So -2 times 1 plus 5 times 0. All right, and then we have one more entry. We're going to do -2 times 0 plus 5 times 1. All right. And now we just want to simplify all of these, and we want to get these entries into nice numbers, right? 3 times 1 is 3, plus 4 times 0 is 0, and that's going to get you 3. So that means we're going to have a 3 in our first entry. 3 times 0 is 0. 4 times 1 is 4, so we get a 4 in the second entry. And then here, this is going to get you a -2 plus 0, so we get a -2 down here. This is 0 plus 5, so this is 5. All right, and then so this is our product. All right, let's see if we can do the same thing with this next one. All right, so let's look at this first matrix. It is a 3 by 3. This next matrix, we have 3 rows and 1 column, so it's a 3 by 1. These inner numbers are the same, so we can just cross them out, and our final answer we know is going to have 3 rows and 1 column. All right, so let's perform this operation. All right, so I'm going to do this first row with this first column. So it's going to be 6 times 1 plus 2 times 2 plus 0 times -3. All right. Now let's move on to the next. It's going to be 3 times 1 plus negative 1 times 2 plus 2 times negative 3. All right, same exact thing with the next one. We're going to do 1 times 1 plus 4 times 2 plus 6 times negative 3. All right, so this is what it looks like unsimplified. Let's just go ahead and simplify it. 6 times 1 is 6, plus 4 plus 0 is going to get you 10 for that first row. Second row is going to get you a 3 minus 2 minus 6. I know it's getting a little tight right there. That should get you 1 minus 6, so negative 5. All right, and then this last one's going to get you 1 plus, that's 8, minus 18. This should get you negative 9. All right, and then this is our final answer, and it is what we expected. It is 3 rows, 1 column. All right, so again, shouldn't be too bad with enough practice. Let's try this one now. All right, this one has 1 row and 3 columns, so it's 1 by 3. This one is 3 rows, 1 column, right? So the inners are the same, 3 and 3. So our final answer is just going to be a 1 by 1 matrix. It's literally just going to be one number. All right, so let's do the first row. So 1 times the first column, so 1 times 2, 1 times 2. Second times the second is plus negative 2 times negative 1, plus the third times the third, negative 3 times 1. So this is going to get us 2 plus 2 minus 3 when we simplify it, and that's going to get you 4 minus 3, which is just 1. So this is just one singular number, one singular entry in this matrix, and it's just 1. All right, now if you look at the next one, it is 3 rows, 1 column. This next one is 1 row, 3 columns. All right, so the 1 and the 1 is the same. So our final answer is going to be a 3 by 3 matrix. All right, so just by flipping it, just by flipping the order of these is going to give you a completely different answer, right? So that's one thing to note, is that multiplication with matrices is not commutative. You cannot just flip it and get the same answer. Sometimes it is possible, and then sometimes when you flip the order, it's not possible. All right, so that's just one thing to keep in mind. All right, so let's just perform this operation. First row, first column is just 2 times 1. First row, second column is 2 times negative 2. First row, third column is a 2 times negative 3. All right, and then we do the same thing with the next one. Negative 1 times 1 is the first entry. Negative 1 times negative 2 is the second entry, and then negative 1 times negative 3 is the third entry in that row. All right, and then we do the same thing with the last. 1 times 1 is the first entry of that row. 1 times negative 2 is the second entry of that row, and then 1 times negative 3 is the third entry in that row. And then we just want to simplify these. Let me write it down here. 2 times 1 is 2. Our next entry is a negative 4, and then a negative 6. And we get a negative 1, 2, and a 3. And then a 1, a negative 2, and a negative 3. All right, so then this is our answer for this matrix multiplication.